Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, you learn about AWS services. As you know, I have already started a series on AWS Glue optimization, and this is the part 2 of the series. So let's get started. Few prerequisites. So this is kind of an advanced tutorial. So it is understood that you understand how to write AWS Glue Job, you understand fundamentals of both glue and lake formation, and you also know how to use PySpark with AWS Glue Job to write your code. So if you know those things, you are good. If you are not, then you should use some tutorial to learn about it. I have also provided 2 tutorials which you can use for learning purposes, and I have provided a link in the description box below. You can simply use it to learn about AWS Glue Job as AWS Glue and how to use PySpark with AWS Glue Jobs. Also, I will recommend, so there's structure which I have put when trying to run this optimization series. So if you can go to part 1 of the series and just see first 6 minutes, it will give you some idea about how I'm going to organize this series, and that will help you understand this series better. So I will recommend you do these prerequisites and then you can move on to the next of the slides and to get the maximum benefit out of it. So let's get started. So what is today's technique? And today's technique is, if you are working with JDBC data sources, how you can do read and write in parallel. So when you are trying to fetch data from JDBC data source, or when you try to write data to JDBC data source, how you can do that in parallel. And of course, it helps improve in the performance. So let's try to understand. For that, we will take a sample table in JDBC database, and I'm going to use the same table for my demo purpose later point of time as well. And this sample table, I'm calling it food demand. Basically, what it is doing is it's showing week by week what meal people have ordered and what has been their base price and checkout price. And it's pretty straightforward and simple table. So what we have got is transaction ID, which is transaction ID for a transaction. Then week by week, we have got per meal, from which center the meal was sold, and what is the checkout price, and what is the base price. And week, we are putting like week in number, like for instance, 120th week, and so on and so forth, like that. And we have total 130,000 rows, so 130,000 rows plus in this table, which we are going to use for our first explaining the concept purpose and then for the demo purpose. So let's move on. So if you're trying to read data from JDBC data source to a data frame using AWS Glue Job, how does your typical code look like? What kind of code people will generally write? What people will do is simply write a simple code, and that is glue context, create dynamic frame from catalog, and from glue catalog, and they simply provide the glue catalog database name and glue catalog table name. And this glue catalog table name is actually a catalog of the JDBC data source over here in the AWS Glue. So people will typically write this kind of simple code, and it fantastically works. And basically what it's going to do is going to read this food demand table from the food demand table using this catalog, which is primarily representing actually your table inside a JDBC data source. It will simply read data from there and populate into a data frame. That's what it does. But the challenge with this code is it is a single query single query read. So means it is going to read through one query. Okay, and that is the problem we are trying to fix. So that is very fine when you are working with small tables, but if you're table has large amount of data and you want to optimize your read performance, then it does make sense that you don't use a single query read, but you go for a multi-parallel query reads. So first try to see, do we have potential for parallel reads or not? And in this example, I mean, there could be multiple way parallel reads can be done, but in this example, I'm going to show you the thinking process for that. So first, let's try to recognize that do we have potential for parallel reads? And what I mean by parallel read here is that I want to read the same data, but I want to be able to run multiple mutually exclusive, non-overlapping queries in parallel to fetch the data. Here in this table, I find the week field. You see here, 146, 147, 155. Week field is something which I see I have potential to do parallel reads. Reason being, if I try to see the record distribution week-wise, it is pretty much consistent. It's roaming around 13,000 records. So total 13,000 records I have per week. So the number of records per week are quite balanced and evenly distributed. That means if I make multiple non-overlapping parallel queries for each week, then I will able to read data, and each read will be an evenly distributed read. Not that it is necessary that I need an evenly distributed read. It could be unbalanced distribution as well. But if you're trying to read data in parallel, then having an evenly distributed read is more, I will say, performance oriented than doing an unevenly distribution. And that's why I show you here. And I took this data set where if I try to see my record distribution per week, it looks very evenly distribution read, more or less 13,000 record. That means if I try to read my data in parallel week wise through mutually exclusive non-overlapping parallel SQL queries, then I can optimize my performance. So basically what I'm trying to achieve here is this. I want to run multiple parallel queries. Well, I'm showing here 10 queries, but not necessarily 10. It could be 2, 5, 6, 7, up to you. You can test for multiple parallel reads, but basically I want to run multiple parallel read queries, so that one query will simply load the data for 146 week, one query will read data for 147 week, one for 155, one for 153, and so on and so forth. And these reads I can do in parallel. And they will of course not interfere with each other because they are mutually exclusive, non-overlapping queries. That is what I'm trying to achieve here to solve the problem of single query read and enhance the performance. So how do I do that? How do I change my code so that my glue job can start reading in parallel? That's what I'm trying to fix here. It's pretty straightforward and simple concept, guys. So what is the solution? Solution is JDBC parallel reads, and that is very straightforward. You take the same code which I showed you earlier, where I'm reading using from catalog method from a catalog database and catalog table. What I'm doing here, sorry, I put the table name different here, but it doesn't matter. I mean, it's more of a typo. It should be food demand at both places, or Postgres public food demand at both places. So don't get confused by that. The table name, there's no change in table name. Table name is the same. It's same glue catalog table name. And then we simply put some additional options here, which I've highlighted here. The first field, and these additional options actually allow parallel read. So first of all, I'm saying hash field equal to week, and hash field equal to week means saying, hey, I want to make a parallel query based on week number to read the data. So I'm choosing week as a field on which I want to partition my data for parallel read query. Second, how many queries you want to run in parallel, and that answer is given by hash partition. He's saying here 5. That means I want to run 5 parallel query. And if you don't provide hash partition, by default, I think it takes value of 7, that it will run the 7 parallel queries. So 5 or 7, these are the maximum parallel query it will run. So it might run fewer than that if data partition doesn't demand more than that. But basically what I'm saying here is that try to read data in parallel week-wise through multiple non-overlapping mutually exclusive queries, and your number of parallel queries should not exceed 5. That's what you're trying to say here. So what this one is going to do, that it's going to run 5 parallel queries to read data week-wise. And anyway, I'm going to show you this in the demo as well, and you will see how it works. So pretty straightforward. By just putting this additional options, you can actually decide on which week you want to do the parallel reads, and how many such parallel reads you want to do. Yeah, both you can do here. Now, few quick tips. First one, if you don't have a hash field which can be used to do evenly distribution of your data or non-exclusive data, you can also use a hash expression. So you can replace hash field with a hash expression, which is nothing but a SQL expression, and this SQL expression can be used to create parallel read non-exclusive queries, right? So instead of saying that, okay, give me for read 146, 147, you can put some expression, and this expression will simply partition your data for the query. And especially important is it should be non-overlapping partition. That's point number 1. Point number 2 is, whenever you're using hash expression or hash field, try to go for even distribution of values, so that it's not across the partition, so that you get the optimal performance. So it is okay even if the distribution is not equal, but it is recommended it should be equal if you want to get the best performance. That's the second point. Third point, the code sample I showed you earlier, that was using from catalog method. You can also use this mechanism with from options method, and I'm showing the example over here. In the from options method, generally you provide your connection type, you provide your connection options, and so on and so forth. As a part of your connection option, where you simply provide your JDBC URL, username, password, database name, table name. In case of Redshift, you also provide your Redshift temporary directory. You can also provide a hash field value over there, and that way you can partition your data. So keep this in mind. This create dynamic frame method where you can use read partition or parallel reads can be used with both from catalog and from options method. Okay, so this was about doing the parallel read. What about the parallel write? Let's try to understand that as the next concept. So here I'm turning the table other way around. I have got a dynamic frame here, which I want to write to a food demand table, okay, using a AWS Glue Job. Let me show you what typical code people will write if they want to, which will result into a single query write. And they will use simple code like this. We are saying, hey, I'm writing from JDBC conf method. Here is my data frame. Here is my glue connection, which can be used to connect to Glue database, so to connect to the JDBC database. Here is my table name. Here is my database name, and then here is my temp directory in case of Redshift. And this will write your data frame into the table in the database. Looks nice again, but if you are using this method, then you're using a single query write method, which is not going to give a very good performance if you have very large amount of data. So how do I convert this into a multiple query parallel write or parallel insert or parallel bulk insert kind of thing? How do I do that? For that purpose, you for instance, two examples. So this is one example. We are using your from JDFS conference method, conf method, and the second one is from options method. That's also a single query write method. It's the same way again. This is a data frame. My connection type could be Postgres, MySQL, Redshift, anything like that. Here is my connection option where you provide your username, password, database name, and table name, and this code also does a single query write. But I want to convert, as I said earlier, into a multiple query write where my data can be written in parallel to my target database so that I can enhance my performance. How does that solution look like? You can configure this code to for the parallel insert for bulk load. Okay, so you can configure your code in such a way that instead of running a single query, multiple parallel insert query run, which are then used to load data in bulk. And how do you do that? And this method, and that's why I've highlighted, can be used only with from options method. So this technique can only be used with from options. So earlier I showed you two ways where you're using from option, another you're using from JDBC conf method. If you're trying to do a bulk insert, that method is available only in from options method. And everything in the code remains the same, where you provide your data frame, your connection type, your connection details, everything remains the same. Only thing which changes here is this bulk size, where you provide a number. If you say bulk size equal to 2, that means there are 2 parallel insert query will run against the table. If your bulk size is 10, then 10 parallel insert query will run and insert data into the table. Keep this in mind when you're doing this. Each of these bulk insert will actually create their own connection. So your target table should allow that number of parallel concurrent connections. That's something you need to take care of. Otherwise, it's pretty straightforward and simple code where you simply add one more option as a part of connection option, bulk size, and the number you put here, that many parallel inserts will run to ingest data into your table. So I told you, things are pretty straightforward, just you need to know how it works and how to configure and what to take care of. So time for a good demo, because the topic is pretty straightforward and demo is even easier than that. What we are going to do here is that I have got an RDS database where I have put that food demand table, all those 130K rows over there. And then I have got Amazon Redshift where I have also created this food demand table, but there is no data over there. And then I'm going to use AWS Glue developer endpoint with SageMaker notebook to run my code, which will do parallel read and parallel write. Now, why I'm using SageMaker Notebook? Because I can use a Glue Job as well, but I want to show you the interactivity of the code, where I can run a single line of code, can show you the output of that. And that's why I am actually using SageMaker Notebook. But if you know how to create Glue Job, then you know how to use this code to convert into a Glue Job. Okay? And that's why I told you earlier as well that you should know how to work with Glue Job, how to write PySpark code, because without those fundamentals, it will be tough for you to understand how this concept works. So let's go to the demo. So here we are in AWS Management Console. My first thing first, I have got a Redshift cluster where, not Redshift clusters, I'm sorry, this is a RDS database. And this is a Postgres database where I have got a food demand table. If I run the query over here, I should see that I have got, if I run, something is happening bad here. So if I change this to, for instance, Postgres, and then Postgres connect, okay, and if I say I want to see the count of food demand here, and run it, I should be able to see, you can see that 130,000 rows in this table. Now, What I'm going to do is that I'm also going to check the distribution of my records week-wise, the thing I showed you in presentations. If I change my query here and say, okay, show me a week-wise count of my rows, which is grouped by week in my table. So if I run this query here, it should show my week-wise distribution. And you can see here, this is my week-wise distribution, roughly 13,000 records per week, and it's an ideal field for partitioning my data for parallel insert query. Okay, so this is my source table. Then I've got my Redshift cluster here, where I have got a food demand table there as well. And if I run a count star on my food demand table over here, it should show me a 0 record because no data is inserted at this point of time. Let's go further. So I have got here my Glue connection. I got to my Glue console. In my Glue console, I have got my database, which is a DojoDB. I have got my table where I have configured my source table, which is my food demand table. It is a Postgres type of database. And my target table is also a food demand table, but this is in Redshift. If I open both of these tables, you can see the schema here. It's a pretty straightforward schema, which I showed you earlier as well. So this is my schema in my source table, which is Postgres. And if I go back and show you the same schema in my Redshift, it's the same schema in Redshift. And as you can see here, so my both source and target tables are catalog, and I'm going to use catalog as a way to connect to my data source and work, wherever possible. So then what I did, I created a developer endpoint. So I created a developer endpoint, and then I created a SageMaker notebook. And then I'm using my code inside SageMaker notebook. So this is the code I have, which I'm going to use, and I'm going to provide this code, by the way, in the link below in the description box, so you can use it if you want at your end. And this is how the code look like. So what I've done here is that just to show you, this notebook is actually a Spark Magic PySpark notebook. That's the kernel it is using. So I'm going to use this code here to demonstrate the whole concept. So first thing first, I need to run this first cell, which is basically importing my Spark context, Glue context libraries, and I'm also creating a Glue context over here. So let me run this code. And this is going to take some time, a couple of seconds, when it will create the Spark, it will create the Glue context and start the Spark application. So let's wait till it finishes and creates a Glue context for us. Okay, so you can see the Glue context is ready. The Spark application has started. The Spark session has started. Now, first I'm going to read my data from my Postgres table into this database using from catalog method, and I'm not using any partitioning here. So just want to show you how generally people write the code and how it works. So if I run this, this is going to read data from my table, but this time it has read the data using single query. Now I make a small change into my code where I'm using this additional options where I'm saying partition my data based on the week, and total maximum 5 query you should run to read the data. So if I run this one, and this one I populated in food, this one I'm populating in food df1. So if I run this code, it's also doing the same thing, but only difference is that it read data using 5 parallel queries where data is partitioned week-wise. Now, just to show that both has populated same amount of data and same data, I am doing this food df.count, which should give me 130,000 plus records. And if I do the same with food1.count, it's the same thing. It will also give me 130,000 plus count. So you can see both are reading the same amount of data, same data, only difference is that one is using partition, other is not using partition. So keep this in mind. Okay. So what about writing back? So when you write back, so this is the code for writing back, but before I come to here, let me show you. This is the code for writing back. But you realize that since you're using from options, and from options actually you have to provide username, password, host name, those kind of things, which is sensitive data. So it is not recommended that you should be it is not recommended that you should be writing this code to or you should be writing this username and password in the code. So what I have done that I have created a secrets manager. So let me go there first and I'll explain the code over here. So I have created a secrets manager, and in AWS Secrets Manager, I have created this one I've created for Redshift in this case, but here I have created all my username. I've stored my username, password, those things in a secure encrypted manner. And what I'm going to do, I'm going to use this additional line of codes over here, which is going to simply read my credential information on demand from the secrets manager. So it's pretty straightforward. You have to provide us. I'm using Boto 3. Then I'm simply this is my secret name. This is my region name. Then I'm creating a Boto session. Then I'm creating a client for secrets manager for this region. And then I'm using this get secret value method, passing my secret name here. I get a response back. From response, I'm reading my secret string, loading as a JSON document, and then in that JSON document, I have my key value pair for username, password, host. It has many other information, but these three which I need, and I'm simply printing the host name just to see if my code has been nicely successful or not. So pretty straightforward code, and again, this is, if you know how to use Python library, this is not a rocket science. You know how it works. So if you run this code, it's simply going to read my login name, password, and host name from my secrets manager. So I don't need to store, I'm not hard coding my data over here. I'm not showing my data over here. So it is safe. Now, after that, I simply use this from option method. And in this case, I'm using bulk size equal to 2. That means I'm saying write data back, but do 2 parallel insert for me. And here is my username, password. Here my Redshift JDBC URL, where you provide your whole JDBC URL, which is JDBC Redshift, your host name, your port number, and your database. This is my table. So I put fully qualified public table name, but if you can only put food demand. But if you put only table name, that assumes that your schema is public. But if your table is in some other schema, then you might want to put schema name and table name, and that's why I put here public table name. That's generally a good practice actually. So put schema name table name. Then since I'm using Redshift, I have to use a temporary directory. That's how Redshift works. So I put the temporary directory location over here, and then simply bulk size equal to 2. Most important feature here which I want to explain, and that is running 2 parallel queries to upload my data. And I simply run this query. Now when I run this query, what's doing that instead of running a single query, it's actually using 2 parallel queries to do bulk insert of data into my Redshift table, and that should be ready any moment now. So once the data is ready, we will go and check into Redshift cluster, and hopefully it works. Yeah, it's taking a long time, then inspect it, and hopefully it will upload data to my Redshift cluster, and I can show you. So it has successfully completed, and I can go to my Redshift cluster and can verify that. I come back to my Redshift cluster, and I simply run the query again. And if I run the query again, you can see here 130,000 rows are inserted into my Redshift database using that query, which is basically doing a bulk parallel insert into my Redshift cluster. So that was what I wanted to explain today, guys. Yeah, hope you like this video, and if you like the video, please click on the like button. Please subscribe to my channel. I always look forward to your comment, your feedback, whether it is for the new content or for you make any correction in any of my, and you guys do make corrections into my things actually, or if you want to discuss something about AWS design, architecture, some solutioning, please feel free to write your comments to me. I'm more than happy to answer you. I try to answer you as soon as possible, but I love discussing those topics in my comments section. So please do write to me. Look forward to your feedback. Yeah, I promise to come back again in a week's time with another such a video. In the meantime, please stay safe and have a nice day. Bye bye.